am Kimberly Lavelle at yourparenthelp.com, and in this video we are talking again about math. I have my trusty whiteboard marker and a whiteboard, but that's not enough. I also need some concrete, right? We always start with what is a concrete representation of what we're working with. This week we are talking about adding and subtracting big numbers. I always prefer to do this in a story method rather than just numbers written on paper. So I always like to talk to students about what might actually be happening. So you could say, you can make a story about, oh, I'm at the aquarium and I saw 257 clownfish in the giant aquarium, plus they also had 329 angelfish, right? So it's even better if I add in the words. Forgive my print. So I might write that down. So this is abstract, right? If I already know that it's an addition problem, I might write it this way. If I didn't know that it was an addition problem, I might just write down the two pieces of information that I have this many clownfish and this many angelfish. I just made a bar graph, or a bar model of addition. So this actually shows part, and then the whole thing is your total. This is actually one way to do a pictorial example. Now, that's a little bit beyond where we normally would start, right? Normally we would start with concrete. What I would highly suggest you do is go online, look up, if you don't already have these, base 10 blocks. These ones are foams. They're kind of nice because they're quiet instead of the clanky plastic, but the clanky plastic is fine too. You also can probably find these super cheap on like Facebook Marketplace or Craigslist or wherever you get used stuff. So I had 257 clownfish. 200. 10, 20, 30, 40, 50, and 7. 1, 2, 3, 4, 5, 6, 7. Now, if I just counted out all those pieces, I would still have my child go back and check that. 250, 10, 20, 30, 40, 50. You'll notice I'm counting by tens. You also could say 5 groups of 10. Don't just say 5, because that 5 is worth 50, not just 5. And then 7. The 7 is worth 7. So I'm counting, make sure I have 7. 1, 2, 3, 4, 5, 6, 7. Again, you'll see I'm touching as I count. Make sure that I actually have the right number. Get that one-to-one correspondence if it's at all still a struggle. So I have my 257 clownfish. I can set them aside. I dropped a fish. I'm gonna replace it. Okay. Then I'm gonna get 300. So I'm not doing anything with these, right? These are my 257. They are hanging out right there. Then I have my 300. And my 20. And since I like to make things challenging, I made 9. So I'm going to get 9 more angelfish. Did I say clownfish? I meant angelfish. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you now have clownfish and angelfish. Let's see if I can show that better. We have a pile of clownfish and a pile of angelfish, right? Not probably what I really want. So what you can do is, some of the sets come with something like this. You don't have to do it this way. But what you can do is have something, right? It's basically just a grid. You could create this really easily. And I laminated mine because I'm a teacher and I do it over and over and over. So And I know a lot of homeschoolers and myself had laminators at home, so you might want to do that. You don't have to. Your choice. I dropped another fish. These poor fish. So all I'm going to do is take all of those pieces and put them in the appropriate spot. I'm going to kind of keep them separate initially, just so that I can see visually what is happening between them. So, what I'm looking at now, if there's a way to show you better. What I'm looking at now looks like this. And, feels awkward. So, 257 clownfish, 329 angelfish. So I could do something like this. I said, okay, well, it wants to know how many fish, how many clownfish and angelfish together there are. So I just need to put them all together. So a child might understand a picture like this. Probably not right away. It probably has to get demonstrated to them on a smaller scale first, so smaller numbers first. But big numbers work. They might also, let me get into the board. They might also think, okay, in one aquarium, some of them, oh, I reversed my numbers, 257. Some of them are clownfish, some of them are angelfish, so what is it all together? And they might really understand that it is all together. And that's where you can say, okay, so part is this, what is the whole thing, the length of the whole thing, but that can be kind of confusing. You could have two circles, and then they're wondering, well, okay, if I put them together, what is that? It's again kind of bridging that gap. So these are all kind of connecting it to pictorial. You could physically show them, okay, you talked about, drawing that way is not working. We have in front of us we have a stack with 2 big squares and another stack with 3 big squares. So they're drawing out what they're seeing here. Then we have 5 sticks and we have 2 sticks. Then we have 7 cubes and we have 9 cubes. 6, 7, 8, 9. So they can draw out a representation. This is pictorial. It's not literally showing it's showing 1 for 1, but it's not showing 10, it's not showing 100. So I would probably write in each of these 100 to show that each of these is worth 100. And they're not trying to add these all up as if everything's equal to 1. You could write on top of these 10, or if you wanted to make these into a block, and then you could write 10 inside, either way. I would probably just do a stick and write 10 on top, just because it's easier. But only if your child can make that connection. So we've gone from concrete to pictorial, right? We can, in some cases, kids have done this enough, they might go straight from concrete to a more complex pictorial, or even abstract and say, okay, well, I need to know how many it is altogether, so I'm just going to add it. And they'll just go straight from concrete to abstract, and that's okay too. That's good when they get more proficient. They might also get to a point where you can tell them this story and they can just draw a pictorial of some kind, whether it's drawing it out, what would we be grabbing if we were using base 10 blocks, what would that look like, drawing it out in a more abstract version of a pictorial, drawing out the circles like I showed before, 257, 329, what is that all together, right? So, at some point then, we have to do the actual adding. So we talked about how to set it up, how to represent it, now we have to actually add it. So, let's start with concrete. Here's what's fun. Kids don't have to go in the order we want them to go in, right? We want them to start here so then they can see that they've got an extra one, right? Now, they don't have to. They can push everything together, and they could even write down that they have, one more board. They could even write down the representation. Okay, I have 500, and I have 10, 20, 30, 40, 50, 60, 70, and I have, and they would count it all up, I have 16. So these are all the pieces I have. This is expanded form. So don't let them write it out. You know, if there's a gap, that's fine. If they want to do circles, this is called a number bond when you bring it all together and write down what it's worth. Now, some kids will get tricked up here, and they might write down, I mean, I've seen so many things, right? I have seen 570, 16. I have seen that they know it's 500, they know it's 7, and then they just stick 16 on there. So now suddenly 5,000. And you can point that out to them if they're decent with place value. Say, this is the ones place, this is the tens place, this is the hundreds place. Now wait, were there 700s? Right? So figure something out there. So again, kind of going concrete pictorial back and forth. So if they do this, then they're going to be looking and say, okay, this doesn't fit. So you can let them know that only 9 units are allowed to stay in this section. If there's more than 9, and there are some boards I've seen that I like that actually have little squares, but you can also just create that really easily. You can just draw out 7 spots or 9 spots, and if there's more than 9, they don't get to keep them. The rest have to get changed. Well, anything, but they have to get changed. Anything above that can get changed. So they'll come up with a group of 10 that can then get exchanged for a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they can match it up. They've got, a real life example. It's right there. Okay, I'm trading this. I like using the different colors to make it easier, but you don't have to. A lot of them are all blue or all, and some are all different colors. Every set is a different color, or every value, like the hundreds might be blue, the tens might be green, and the ones might be red. So now they've traded it in, and again, you can only have 9 pieces here. So they have to make sure that they only have 9 or less. They only have 8. If they had 9, great. If they had 10, they would be again recognizing that they have to trade it for 1 more, and it would move over again. Now, well, let me finish this. So I've now got an appropriate number in each section. So now I can redo this and show that I have 586, right? This became this. So they worked through that and they got to their total answer of 586. They've gone from concrete, this would count as pictorial, the number bond, and then they could write it out as abstract if they go back to the addition problem and write in their answer. Now, no, I'm not going to get into too much complication with that. I do want to show you kind of how to talk to them about big numbers more another time, but this is already getting a little bit long. So we'll keep it simple. Concrete, I would recommend getting base 10 blocks. There is another thing that is called Digiblocks. I have not played with it yet, but I'm planning on getting some because they look really cool. If you look them up, it's the 10 pieces fit inside of a 10 block. What they've got is their 10 block, and then 10 of those fit inside of a 100 block. So instead of like trading like I just did, you're like, it's actually those still are there, right? All 10 are still there, but then they're enclosed, and then they go to the next one. So it's kind of a cool concept. I liked that. I'm planning on getting some and playing with those. They're not a sponsor. I just noticed them and plan on getting some. And I want to make sure I covered everything. Concrete, pictorial is a few different ways. You can draw it out. You can show the hundreds, tens, ones, anything to represent this, right? And then the abstract is just writing that algorithm out. Oh, that's what I wanted to mention before we stop. So when you are going to show them how to work out an algorithm, we all want to jump here, right? And then say, okay, well then you do 7 plus 9, you carry the 1. Slow down on that. It doesn't matter that much. You don't even have to go here until they've done a lot of practice with the rest of it, because they need to understand that you're not carrying the 1. That's not what we did. We traded the 10 ones for the 1 10, right? We put it where it belongs because 10 ones don't fit in each section. Each section can only have 9 of that unit. Whatever the unit is, it can only have 9. You can only have 9 ones, it can only have 9 tens, it can only have 9 hundreds, it can only have 9 thousands. Anything more than that has to get traded up, has to get exchanged, has to, it's a group too big. So we've got to take it over. So it's not carrying a 1, it's carrying a 10, and you can talk about that. So when you're ready to start introducing it, but don't rush it, you can say, okay, well, we added 7 and 9, and you can even say, I want to show you this cool thing that might make it easier for you. And if their eyes glaze over, they're not ready for it, don't worry about it. 7 plus 9, we said, was 16. But 16 doesn't fit down here because you can only put 1 in each row. What we did was we took that 10, right, and we actually moved it over to the next section. So I'm going to move it over so that it gets added up with the other 5 and the other 2. And then I'm going to add all of those together. 5 and 2 and 1 we decided was 8. And then we had our 3 and our 2, and that was 5. So if you notice, I'm not sticking to here. I'm constantly referencing back to the concrete that they're actually looking at, playing with, seeing. We want to constantly have like that. This can't be abstract by itself. It has to be rooted in what the concrete is if we want them to really understand how the numbers work. So please, please, please always be referencing back. Don't rush this. When they understand this really solidly, this stuff just flies. But when you try to get this to fly, it might fly for a minute, and then they get to something new, and they don't know what to do with it. Okay. I hope that helps and gives you some good ideas on how to work with your child on multi-digit addition with concrete and pictorial and abstract. And there's so much more we can talk about, but we want to not make this video any longer than it is. I will see you again soon.